Hello, we are discussing about GATE 2014 ECE paper. In the magnetically coupled circuit shown in the figure, 56% of total flux emanating from one coil links the other coil. Okay. Out of the flux emanating from one coil, only 56% of total flux is linking to the other coil. Find the value of mutual inductance. Mutual inductance is indicated with M. M is equal to, equation is K times of square root of L1 into L2. L1, L2 are going to be coils. This is L1 and it is L2. So which is going to be K times of 4 into 5. So M is equal to K times of root 20. This is equation 1. Then what is meant by this K? K is equal to coefficient of coupling. Coefficient of coupling. Coefficient of coupling specifies how effectively one coil is going to be, the flux generated by one coil is linking to the other coil. So coefficient of coupling will give the information about useful flux. Useful flux, that is how much of flux is going to be linked to the other coil from one coil by the total flux. Okay, so since it consisting of two coils, K is going to be found from square root of K1 into K2. Square K is equal to, calculated as square root of K1 into K2. Okay, and K1 is equal to coupling factor of first inductor. K1 is coupling factor, that is coefficient of coupling of first inductor, that is first coil. So that you can write it as, this is defined as useful flux. Useful flux. Useful flux coupled to coil 2. Useful flux coupled to coil 2 divided by total flux. Total flux emanated by coil 1. What is the total flux emanated, that is generated by the coil 1? Out of that one, how much effectively it is coupling to the coil 2. So whichever amount is going to be coupled to coil 2, that will be called as useful flux. So K1 is equal to useful flux coupled to the coil 2 divided by total flux emanated by coil 1. So this is given as 0.56, because 56% of total flux emanating from one coil, that one coil can be coil 1 or coil 2, and linking to the other coil is only 56%, so it is 0.56. Similarly, K2 is also, okay, useful flux coupled to coil 1 divided by total flux emanated by, that is generated by coil 2. So this is also 0.56. So now you are writing K value, which is nothing but 0.56 into 0.56. 0.56 whole square, square and square root get cancels. What you will get is K is 0.56. Okay, so M value is equal to 0.56 into square root of 20. So 0.56 into square root of 20 is 4.47. So the value is going to be 2.5 Henry. 2.5 Henry mutual inductance. So mutual inductance is K into square root of L1 L2. Directly you can take K is equal to 56. But whenever the coils are going to be given different percentages, then you must go through this procedure. Okay. So the right answer for this one is 2.5 Henry.